This video looks at the 2019 higher level question 1 orthographic projection. It's a pictorial view of a mobile lunar camera is shown in figure 1. Also shown is a 3D graphic of the camera. There are 4 parts to this question. Part A is to draw an elevation in the direction of arrow A. Part B is to project a plan from the elevation. Part C, project an end view in the direction of arrow B. And part D, to determine the true shape of surface S. There are a couple of things to watch out for this question. It's quite a large question, so if using an A3 page, you need to be very careful about positioning, and I'll look at that in a moment. A few other things to watch out for. You're going to need to locate the true shape of surface S. So there's 2 ways we can do that. We can use an auxiliary, or we can rotate it, and we'll look at both of those solutions later. And we also need to watch out for where the cylinder at the front of the object intersects with that sloping surface. So having a look at our board, when starting a question like this, I think it's really important that you locate the total size of all of the views. And we need to position our views correctly. So we've got an elevation, plan, and end view. Our arrow for the end view, arrow B, is looking in at the left hand side of the object, which means the view needs to go on the right hand side of the elevation. So I need my elevation on the left, the end view on the right, and the plan is going to be positioned directly below the elevation. So first, let's have a look at the total size of the object, of the elevation. So the elevation, looking at the horizontal distance of it, starting at the right hand side, it's 170, then we've got 20 millimeters, and that's the total block part of it. But then we've got the bit of a cylinder sticking out at the front, so that's another 30. So our total width for the elevation is 220. The height for the elevation, counting up on the right hand side, is 40, 10 millimeters then above that, 25 and 40, giving me a total of 115. So I can create a box here that the elevation is going to fit into, that is 115 tall, and it is 220 wide. So 220 by 115. Now, to ensure that this question fits on the A2 page, if you have an A3 page like this one, you need to be very careful. If you have A2, you'll have no problem fitting it on. So for A3, I've come down 135 millimeters from the top of the page. That gives me my XY line, and I've just come in approximately 15-20 millimeters from the left hand side of the page to get this start point. It needs to be those positions, otherwise it will not fit. So our plan is going to be directly below it. That's going to have the same width, so that's going to again be 220 millimeters wide. I'm just going to leave 10 millimeters between the XY line and the plan. Again, just because of space on the page. The depth of the object, how far down this way it's going to come, we need to look at the question again. So looking at the right hand side of it, kind of the top part of it, we've got a 90 for one part of it for the width of the cab, and then we have 25 millimeters for the track. Now there's a track on the opposite side of the question also, so we're going to have 25, 90 and 25 again, giving us a total of 140. So 140 millimeters down from the 10 millimeters down that I've already measured gives me this point down here. So our plan is going to fit into this box. And now for the end view needs to go on the right hand side, as we said already. So taking your lines at 45 degrees. That's going to give us the depth. And the height is going to be the same as it is in the elevation. So our elevation, plan and end view the entirety of them is going to fit into this box. So now I know that I don't need to worry about something not fitting, the question not fitting on the page. All the plan fits into this box, all the elevation into this box, and all the end view in here, so the whole thing fits into the one spot, and it all fits on the page, so I know that it's going to fit. Okay, so what I'm going to start with first is the elevation. So we've looking in the direction of arrow A, we can see the tracks, which are going to be here somewhere. We've got a bit of the cylinder sticking out here at the front, and then we've got the cab, which is going to kind of come up this way, sloping up along that way, and then the window bit is going to be here somewhere. There'll be another slope here at the back. So first off, I'm going to draw in the tracks. So the total length of the box that the tracks would fit into is 170 millimeters. So it's 170, and it gives us a height of 40. So the box that they fit into is up 40. Now, inside in this, we are told that there is an arc at the front and at the back, and we're just told that it is radius R. We don't know the length of that radius. So what we're going to do is we need to figure that out. So from here down at the bottom to the center is going to be R, and from here to the top is going to be R also. The radius is going to be half whatever the total height is. Total height here is 40, so it's going to be radius of 20. Front and back. So we can set our compass to this distance now. As always, I prefer to mark distances on my page and then set my compass, rather than setting my compass on, let's say, it's set square like this, because if I hold it, I let go, it swings in, it squeezes in a little bit because of the springiness of it, and then I'm not getting an accurate curve. So set it up, test it, check it, and then draw my curves. So that gives us both of them there. To find where the point of contact is between our line and tangent, draw vertical lines. And then we can darken in the correct pieces along here. Now, next part we're going to have a look at the cab part of this. So the cab is going to be up along here, and there's a sloping edge here on the back of this. So that's starting 10 millimeters above the tracks. So measuring up 10 millimeters here gives me that point, and the sloping ends 50 millimeters in from the back. So in here 50, and I can draw that line there. The cab is going to come out here 25 millimeters, and then it comes out a further 45 based on the arc that we're given in the question. So we'd see that more of that inside the plan. So our 25 and 45 gives us a total of 70. Coming out along here, distance of 70, and down a thickness of 10. So that 10 is just the kind of the ridge above where the window starts. And our radius 37. So I'm marking in this 25 millimeters. So that's where our window is going to be. So what I've come out here is 25 and then a further 45. The 25 is from the sloping point, that's where the window is going to come down along this way. The 45 is where the overhang of the window is up here at the front. And then there's a radius 37, so that's the inner part of this window coming down along in here somewhere, and that measures from the 25. Now just to find where the bottom part of that window is, it's coming down 40 millimeters from the very top, because that's what it shows us in the question. On the right hand side there we've got a 40, so we're coming down 40 from the very top. and that's giving us the position for our window, so coming out along there. Okay, so there's a few bits of that I can darken in at the moment, and darken in here, darken in the window at the front, and a bit of the overhang here also. Okay, so next what we're going to do is we're going to find the front of this here. So there's a cylinder piece here at the front, and as we're looking in from the side of it, so perpendicular to the axis, the cylinder is going to appear as a rectangle. So we'll be able to put that in a minute. First we need to find the bit of the front of the body part of this here. So we'll be coming up along here somewhere and sloping back along that way. So the front of this is 20 millimeters in front of this. So it's 170 plus the 20. This is where that 20 is coming from. So it's going to be out along here somewhere. That's the very front of it. The height that the front of that is at the same height as our slope is here at the back. So if you look at the question and follow where the 10 millimeters is at the very back of the right hand side of the question, and follow the light construction line that comes all the way to the front just above S, that gives us the height that is at. So this is going to be at this height coming along here and giving me that corner. So we'll need to work out the slope going back along here. We're not given a distance for how far out it is from the window or from anywhere back there, but we are given a different dimension. So we'll have a look at that in a moment. First, I just want to have a look at the bottom. So the front of this does not come all the way down to the bottom. As you can just there to the bottom left corner of surface S, there's a height of 10 millimeters. So if we mark that height at 10 millimeters, it comes up to there. So this is the bottom of it. So that's the bottom part. Now there's also a hidden detail that runs the length inside underneath this, as we're to take it that it is sitting up above the ground, above the tracks. So there's a little bit of visible line there at the back, and then that's going to come all the way up to our sloping point there. So that gives us this much. Now what I'm going to do is I'm going to stick in the sloping piece here at the front. We're not really given a position of where how far back this way it goes, but we are given a dimension. So looking at the question again, there's a distance of 70 millimeters, and that's a sloping distance of 70. So if I measure, set my compass to 70 millimeters, so I'm just going to mark 70 millimeters along there. So from here to here is 70. I'm going to set that distance on my compass, and then point my compass on the point here, swinging an arc so that it cuts the line up here somewhere, the horizontal piece at the bottom of the window. That gives me the end of that slope. So point my compass on here, from here to this point is going to be 70, where it cuts that line gives me the point on the line that I'm looking for. So that completes the body of this. The next part of this now is the bit of the cylinder sticking out here at the front. We're told it's a radius 20, and we're also given its horizontal starting height, or how high up it is off the ground. So we're told that if you look at the dimension line, so looking at the front of that, the cylinder, the radius 20, if you look at the center point of that circle, follow the line out to the right hand side, you see the distance of 30. That's at the same height as this point here. So our cylinder is going to be 20 above, 20 below that point. So we can mark up 20 and mark down 20. Radius is of 20. So, and as we said, it's going to appear as a rectangle. And we can see where that intersects into the front of that sloping surface there. Now that's almost the elevation complete. The only thing that's still to do is mark where surface S is. So surface S is going to be out here in this part. We're back distance at 20. So I can project this up here. Just draw this line up. And that part there is surface S. So I'm just going to shade that in a color just so that it's a little bit clearer. Okay, so that completes the elevation. The next part now we're going to look at is drawing the plan. So our plan is going to be directly below it, and we're going to, a lot of our distances, our lengths, we can just project straight down, and the widths we'll need to look at our question for. So I'm going to start by drawing the tracks and finding just the position for the body. So they are 25 millimeters, the tracks are wide. So 25 here, and 25 in on this side. So now when we're working with the body, anything to do with the body, it's going to be located in this section of it here. So the tracks are going to be here and here, this part of it, and here is going to be the body. So as the tracks are fairly straightforward, we might as well just finish them now. So we have the front and back of them, and this here is the tracks of this question completed. Okay, so next we're going to have a look at doing the body part of it. We're going to ignore the cylinder for the time being. We'll locate its position, so I can find its position. It's 45 there, so this is the center axis for the cylinder. So it's going to be along that center line, and it's 20 millimeters either side, so I can just mark that. So this here is the approximate position of the cylinder. It's not finished. There is going to be a bit of a curve going in there, but we'll worry about that a bit later on. Now, so what we're looking at is finding the top of the cab. So we'll start with this corner here. This corner is going to be located directly below it. So taking your point, projecting it down. That's going to be a solid line the whole way across. And that there completes the back of the question. So we've got our sloping surface coming down along this way. It's going to come in this way now, and then there will be a semicircle. The center for our semicircle is located from our 25 up here. Projecting this down, and it's going to be along this line here for the center. So again, setting our compass up, point for a compass on our axis, pencil on one side, check that it lines up, and that gives us our visible arc there up on top. So this comes down as in line with that there. The next part of this is there's another window underneath here. The window is in underneath here, and it's radius 37. So let's mark that in, radius 37. Now, as this is underneath looking down, it is going to appear as hidden detail. So it's a hidden detail arc. So we can draw that in that way. And then there's also going to be a little bit of hidden detail because we've got a bit of a window, or the edge from the window, where the window meets the wall, goes in there. So that's this part looking down on plan. This dotted line now is the edge view of this plan, of this window in plan. Now, so we're almost there with the front of this with the plan. This edge here, we've got it so it's one line meeting another line, change direction, so that's going to give us an edge in plan. So that gives me this line, and then it's going to sloping down but it also gets narrower, but we'll look at how it gets narrower in a moment. We'll do that in so we'll look at that part of it. So that's going to happen down here with surface S. So it stays the whole same width the whole way down as far as here. Now I'm not going to darken that in yet because it's going to be affected by this arc, but I can darken in a small portion of it, bits that are outside the cylinder. And then we want to put surface S in here somewhere, so it still sticks out a little bit beyond there. When surface S is going to be down in this corner. If we look at the question, it comes in 12 millimeters from the outside, 12 mil and 12 mil on this side also. So this slopes in along this way. Same on the opposite side. So this surface here that we're seeing an edge view of, that's surface S. This one down here is surface S. Cylinder still needs to be drawn in, but we'll come back to that after completing the end view. So this is most of the plan complete. This sloping surface here is this one. The flat surface here up on is the top of this here. We've got our window, which is recessed in inside it, so that's going to be a dotted hidden detail arc line there. And then we have a few more bits that we're going to be working on up here, but we'll come to them later on. Now, in our end view, we are going to complete this up here now. We shouldn't need to measure anything anymore, as we have the widths of the widths of everything here, and we have the length and the heights of everything up here. So we don't need the length for anything. So we've got the heights that we can take and the widths that we can take from here. So again, let's start with the tracks. They're kind of straightforward. So project them up at our 45-degree angle. And we can take the heights from our elevation. So these come up. Height is taken from the elevation. So I get the full width of the track here and here, and I can darken in those bits now. Okay, the next bit, working our way up, we've got a gap underneath the bottom of this here. The gap goes from one side to the other across the tracks, so I can mark that distance up here. So taking the height from underneath this, it's going to project across. This shows me the bottom part, so the clearance underneath the cart type of thing. Progressing up along, let's find the front, this front edge here. So surface S, front of that is there. That gives me that height. I'll come back to this one for surface S later on, and we'll find where the bottom of the window of the cab is. So that's running along here. The top of the cab, or the top of the window, is this line, and then the very top of the cab we already have. Full width of our object is just inside the tracks, so I can project these lines up and stay working inside that. So lines go all the way up. So solid line across the top. We've got our window here. Now this window is going to be, it's a solid line going the whole way across here also. And the same applies for the bottom of the window. But we need to locate our window, so our window is going to be in here somewhere. It's not going the full width of it, so we can take our distances from plan. So over to the extreme edge of the object, up at the 45 degrees. here, and here. So this is a curved surface, although it doesn't appear. Same for this one up here. So now I'm going to just find surface S here in the end view. So we're going to project the widths across from the plan. So looking here at surface S, front point, they're taking this point here, front here and here. So it's this point and this point. Gives us a height that we're working with, and we also have this distance. So I can take that and project this up to intersect the height from the elevation. So that gives me this point here. For the outer point, that's given me this one. Following that up into the elevation gives me this height. So I can follow that across, follow it across up over here, going to this point over here. So I can darken in this line. And this, so this is surface S. The left hand side of this is darkened in the same way. So if we take each point, taking this one, following this up into the elevation, it's the lower point. Following it, bringing it over into plan, or into the end view, sorry. Line comes across, projected up here, low point. This is that low point that we're looking for. So follow the line, up at 45, up along here. So it's along that line there somewhere. This same point in the elevation is this one. So it's the lower point on surface A, on the back surface. This comes across, giving me that one. Finally, the other edge of this is this one, so let's follow that across. Comes up here. It's along this dark line here somewhere. The height of it, where it intersects the sloping line, that comes across. That gives me this point here, so this is the other side of it. The equivalent on surface S on the other side. Okay, the next obvious thing to put in here now will be the center for our cylinder. So let's find that. So we'll take that from the plan, across, up along this way, and its center is located along this point, so at the same height as this point, and it is a radius of 20. So following, marking that radius 20 here. Set the compass to the 20 from here. It just appears as a circle in the end view. So we can darken in a few bits and pieces now that are around this also, so our line is going to come across as far as that. And that completes the end view. Now with the end view we have one more thing that we need to watch out for, and that's the back of this object here. The back of this object. So this here has a straight edge going across the back, which indicates that there's going to have to be something to show that over here also. So that is going to be at this height, so we're going to have a hidden detail line running across here. So across all of this here. We're not going to see it when we have a visible line, that takes precedence, but we do have a hidden detail line running along here. And there is the finished end view. Okay, so if we just have to look at the question again for a moment to see where we are. Draw an elevation in the direction of arrow A. That is completed. Okay, don't have any more to do there. Project a plan from the elevation. We're mostly there with that. We still have the cylinder to put on at the front. Part C, project an end view in the direction of arrow B. That's done. Don't have any more to do there. Then determine the true shape of surface S. Yeah, that still needs to be done also. So let's look at putting the cylinder on. So our cylinder in our end view is a circle. In our plan appears as a rectangle, although it's partially cut by a sloping surface. And then down here in plan, it is going to be a curve here, so it'll be it'll be part of an ellipse. The front of it, the bit that sticks out and doesn't interact with any of the other part of it, is very straightforward. That is just a rectangle. But from here back now it's going to change. It's going to start interacting differently. So what we need to do is we need to find points on the curve that we can plot coming back along this way to find what it's going to look like. So what I need to do is I'm going to divide my end view, the circle, the cylinder up in the end view, with my 60-30 degree set square. So dividing this up 60-30, now we only need to do the top half of it, as the bottom half of it intersects normally with the bottom half of it is just a cylinder coming straight into a flat surface that's perpendicular to it. So it's not cut at an awkward angle. So dividing this up 60-30, that's going to give me a couple of points. So we'll label them. This here is point 1, 2, 3, 4 for the very top, 5, 6 and 7. It's really important that you label these points so that when it comes to moving them around down here, you can locate them nice and easily. Now what I'm going to do is I'm going to find these same 7 points over here in the elevation, and to do that they need to be projected just from one view into the next, so horizontal. They're going to stay at the same height, one view across, and where they intersect the sloping edge is the point that we're looking for. So that's point 2 and 6. Next one, 3 and 5, project that across. This point here, 3 and 5, and then the top one we already have, that's point 4. Point 1 and 7, or 7 and 1, are located just at that point down there. So now we have the setup of this done. It's just a matter of locating each of these points in plan. So each point is located the same way we've located any other point. So if we take this example here of how we found the corners of surface S, if I have a point, I knew its distance out and I knew its height, I was able to find that over here. Here I have the same thing. I have its distance, so it's just its length across this way, so it's going to be down there somewhere, and I also know how far up this way it's going. So if we take, for example, point 2. Point 2 is going to be somewhere down along this line. So it's this distance in from the left. This same distance in from the left. It's not going to change no matter what we look at the question. Point 2, its distance up from the front of the object or from the back of it is going to be the same as it is in the end view. So I can project my point down here into the plan. So just bring a line down into plan where it intersects here. That there is point 2. So I'll just highlight that in different colors so it's a little bit clearer. So 2 and 6, this projects down that way, and from here projecting down our 45-degree angle. So we have point 2 in both our views, in the elevation and the end view. If I have it there, I can project it down into the plan, and I project it down into the plan this way where the two lines intersect, gives me point 2 that I'm looking for. I'm going to do the same thing for my other points. So I do the same thing for point 6. Project that down. So project it into the plan, point 6. Point 6 we've already brought down, it's on the same line as point 2. This is point 6. Do the same thing for 3 and 5, so we can project that into the plan, taking point 3 from the end view onto the XY line, same way we're projecting any lines from one view into the other. This gives me point 3, point 5 the same way, so down into the plan, So on the same line that we've just used for point 3, so 3 and 5 they're brought down, this is point 5. And finally point 4, it's already on the center line, so we have that. And this is point 4. So now joining up each of these points, so this is 1 and 7 here also. So joining all of these 7 to 6. So joining each of them 3 to 2, down here to 1. And that gives us our curve that we're looking for down here in plan of how this cylinder is cut by this sloping surface. A few more bits that we need to do just to finish this off. You can see here this point needs to be brought in just a little bit closer. It doesn't exist. So I just need to remove that line there as it doesn't exist on top anyway. So this line running along here that I had dark is a hidden is not there at all. So we just have a hidden detail line then that needs to go in here at the front, which is this line here. The front of this underneath at the bottom is still visible. It's almost our question complete. We have one final thing that we need to do. We've just already put in our hidden detail. The final part of this question now is to determine the true shape of surface S. There's two ways that we can do this. We can take an auxiliary view and project our distance off down along this way, or we can rotate this surface and draw it up here, so that if we rotate this around, so from this position, rotate it around so that it's now horizontal, when we're looking in at the front of it from this view in our elevation, we'll see the true shape of it. That's the method that I'm going to use. It's the quicker method for this. So I'm going to take this point. This is the point I'm going to use as my axis. I'm just going to grab that surface basically and swing it around here until it's horizontal. So I'm taking this point, swinging it around here, projecting that up into the elevation, and then taking our points across. So we've swung this side of it, the wider part of it, so that point's going to come across. The bottom point, the height, comes across also. So the true shape of surface S is located here. So this entire piece here is the true shape of surface S. And label it as so. Okay, so just a quick recap on what we did there. Took this, rotated around until it was horizontal, so that we're now looking straight in at the front of it, projected that up into the elevation, and found, brought the same points for their heights across. So this point comes across to here, this one comes across to here, and that gives me the true shape of surface S. So that completes 2019 higher level question 1.